Hey everyone, welcome back. In the last two videos, we've talked about what version control is, why it's necessary. Additionally, we've learned how to install Git. In this video, we will take our first steps with Git. When starting with Git, there are a bunch of concepts that we need to learn to understand how things are organized and how our files are tracked. We'll introduce some of the main Git concepts. We'll dive into all of them as we expand our Git knowledge. Let's start by setting some basic configuration. Remember when we said that a VCS tracks who made which changes? For this to work, we need to tell Git who we are. We can do this by using the git config command and then setting the values of user.email and user.name to our email and our name like this. We use the -- global flag to state that we want to set this value for all Git repositories that we'd use. We could also set different values for different repositories. With that done, there are two ways to start working with a Git repository. We can create one from scratch using the git init command, or we can use the git clone command to make a copy of a repository that already exists somewhere else. For now, let's start by creating a new directory and then a Git repository inside that directory. For example, let's use the mkdir command to create a directory called scripts, and then a Git repository inside that directory. So when we run git init, we initialize an empty Git repository in the current directory. The message that we get mentions a directory called Git. We can check that this directory exists using the ls-la command, which lists files that start with a dot. We can also use the ls-l.git command to look inside of it and see the many different things it contains. This is called a Git directory. You can think of it as a database for your Git project that stores the changes and the change history. We can see it contains a bunch of different files and directories. We won't touch any of these files directly. We'll always interact with them through Git commands. So whenever you clone a repository, this Git directory is copied to your computer. Whenever you run git init to create a new repository like we just did, a new Git directory is initialized. The area outside the Git directory is the working tree. The working tree is the current version of your project. You can think of it like a workbench or a sandbox where you perform all the modifications you want in your file. This working tree will contain all the files that are currently tracked by Git and any new files that we haven't yet added to the list of track files. Right now, our working tree is empty. Our shiny new Git repository can now be used to track changes to files inside of it. But before jumping into that, let's check out our current configuration by using the git config -l command. There's a bunch of info in there, and we won't cover all of it. For now, pay special attention to the user.email and the user.name lines, which we touched on briefly in an earlier video. This information will appear in public commit logs if you use a shared repository. For privacy reasons, you might want to use different identities when dealing with your private work and when submitting code to public repositories. We'll include more details about changing this information. Okay, our repository is ready to work, but it's currently empty. Let's create a file in this repo. We'll start with a basic skeleton for a Python script, which will help us demonstrate the Git workflow. As with any Python script, we'll start with the shebang line. For now, we'll add an empty main function, which we'll fill in later. And at the end, we'll just call this main function. All right, we've created our file. This is a script that we'll want to execute. So let's make it executable. And then let's check the status of our repo using git status command. We now have a file and a working tree, but it's currently untracked by Git. To make Git track our file, we'll add it to the project using the git add command, passing the file that we want as a parameter. With that, we've added our file to the staging area. The staging area, which is also known as the index, is a file maintained by Git that contains all of the information about what files and changes are going to go into your next command. We can use the git status command to get some information about the current working tree and pending changes. Let's check that one out. We see that our new file is marked to be committed. This means that our change is currently in the staging area. To get it committed into the .git directory, we run the git commit command. Let's try that now. When we run this command, we tell Git that we want to save our changes. It opens Visual Studio Code Editor where we can enter a commit message. If you want, You can change the editor used to your preferred editor. In our case, this computer has Visual Studio Code configured as a default editor as we selected in the installation steps. The text that we get tells us that we need to write a commit message and that the change to be committed is the new file that we've added. For now, let's enter a simple description of what we did. We'll say that our change is creating an empty all_checks.py file, then save and exit. And with that, we've created our first Git commit. As we mentioned, that any Git project will consist of 3 sections: the Git directory, the working tree, and the staging area. The Git directory contains the history of all the files and changes. The working tree contains the current state of the project, including any changes that we've made. And the staging area contains the changes that have been marked to be included in the next commit. So it might be helpful to think about Git as representing your project, which is the code and associated files and a series of snapshots. Each time you make a commit, Git records a new snapshot of the state of your project at that moment. It's a picture of exactly how all these files looked at a certain moment in time. Combined, these snapshots make up the history of your project, and it's information that gets stored in the Git directory. Now, let's dive into the details of how we track changes to our files. When we operate with Git, our files can be either tracked or untracked. Tracked files are part of the snapshots, while untracked files aren't a part of snapshots yet. This is the usual case for new files. Each tracked file can be in one of 3 main states: modified, staged, or committed. Let's look at what each of these mean. If a file is in a modified state, it means that we've made changes to it that we haven't committed yet. The changes could be adding, modifying, or deleting the contents of the file. Git notices anytime we modify our files, but won't store any changes until we add them to the staging area. So, the next step is to stage those changes. When we do this, our modified files become stage files. In other words, the changes to those files are ready to be committed to the project. All files that are staged will be part of the next snapshot we take. And finally, when a file gets committed, the changes made to it are safely stored in a snapshot in the Git directory. This means that typically a file tracked by Git will first be modified when we change it in any way. Then it becomes staged when we mark those changes for tracking. And finally, it will get committed when we store those changes in the VCS. Let's see this in action in our example Git repo. First, let's check the contents of the current working tree using ls-l, and then the current status of our files using the git status command. When we run git status, Git tells us a bunch of things, including that we're on a master branch. We'll learn about branches later. For now, notice how it says that there's nothing to commit and that the working tree is clean. Let's modify a file to change that. So let's add a bit more content to our script to see that in action. We'll add a function called check_reboot that will check if the computer is pending a reboot. To do that, we'll check if the run/reboot required file exists. This is a file that's created on our computer when some software requires a reboot. And of course, since we're using os.path that exists, we need to add import os to our script. Alright, we've added a function to our file. Let's call git status again and see the new output. Again, Git tells us a lot of things, including giving us some tips for commands that we might want to use. These tips can come in real handy, especially when we're familiarizing ourselves with Git. See how the file we changed is now marked as modified, and that it's currently not staged for commit? Let's change that by running the git add command, passing the all_checks.py file as a parameter. When we call git add, we're telling Git that we want to add the current changes in that file to the list of changes to be committed. This means that our file is currently part of the staging area, and it will be committed once we run the next Git command, git commit. In this case, instead of opening up an editor, let's pass the commit message using the -m flag, stating that we added a new function called check_reboot, and then pass the commit message that we want to use. So in this case, we'll say that we've added the check_reboot function. So we've now committed our stage changes. This creates a new snapshot in the Git directory. The command shows us some stats for the change made. Let's do one last status check. We see that once again, we have no changes to commit, because the change we made has gone through the full cycle of modified, staged, and committed. With that, we've demonstrated the basic Git workflow. We make changes to our files, stage them with git add, and commit them with git commit. Remember that the only way to get familiar with these concepts is practice. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will interact with some advanced Git